Hey everybody, Mr. Cellerol here. Really appreciate you coming and checking out the answer key video. This is an answer key video for R1.5. And so I'm just going to go through not all of them, but just some of the highlights that I think you should pay attention to. Question number 1 is pretty straightforward. What you're going to be doing is using a position versus time graph to answer some questions, describe the motion, and then solve for the velocity using a position versus time graph. And so this is an important skill, right? If we have a position versus time graph, the velocity between any 2 points is just the slope of the line. So for 0 to 2 seconds, if you find the slope, it would be 2 meters per second. I'm not sure why that's not drawing. Okay. And then, another thing to keep in mind is that, so if you find the slope for any of these segments, that's what the velocity is going to be. And notice here, the slope is negative, so that's why you get a negative velocity. Okay, and let's see, number 2 we can move from. A lot of this is just reviewing of interpreting position versus time graphs. Here, number 3, you're writing an equation to model a position versus time graph, and then using it to solve a couple problems. Number 4 is just to show you that texting and driving do not mix, do not do it. A little physics example of why that's so dangerous. Number 5, you're just going from a written description to a position versus time graph, and then to a velocity versus time graph. And that's the same with 5B. I forgot to draw the rest of that in there. Number 6, again, pretty straightforward. For the slope, you just find, or for the velocity, you just find the slope. For the displacement, 6B, it goes from 10 to 60. So that is a difference, or it traveled 50 meters. So that's 50 meters there. Again, then writing the equation and solving a problem. Number 7 is where kind of the focus of the day is. Number 7, we're going from a quantitative, so a position versus time graph with numbers on the axis, to a quantitative velocity versus time graph. And so how this works is that if we need to know the velocity, right, we can just find the slope here. And in this case, the slope is 1 meter per second, if we find the slope there. And so if we know the velocity the whole time is 1 meter per second, then on our velocity versus time graph, we know through the 4 seconds, the velocity is 1 meter per second. And so that's what you're going to do with all 4 parts. B and C as well. Find the slope on the position versus time graph. That's your velocity on the velocity versus time graph. Number 8 has the main idea I want you to get here, and that is this. It's really asking you, so in 8B, on problem 7A, how far, what was the displacement? How far did the object travel? And so you can see that the object traveled from 0 to 4 meters, so the displacement was 4 meters. And then it asks you in part C to find the area under the velocity versus time graph. And so here, if we zoom in and we look at the area under this velocity versus time graph like a rectangle, if we need to find the area of this rectangle, how would we do that? Well, we can just multiply the width by the length, which is 4. And so we have, if the units are 1 meter per second times 4 seconds, well, that's just going to be 4, and the seconds are going to cancel out, so we're just left with 4 meters. And so we're seeing that we know that the object traveled 4 meters. That was the displacement. And that's also the area under the velocity versus time graph. So an important takeaway from this homework is that the area under a velocity versus time graph it tells you how far the object traveled. For the first scenario, Angela and Blake are running at each other. It's asking you to fill in the positions at these different times and then make a position versus time graph. And then it's asking you to find the slope of Angela and Blake's lines. And really, this is review. The slope is the velocity. And so we find that Angela is running at 5 meters per second. Blake is running at negative 3 meters per second because Blake's running in the opposite direction. So it's negative. And then it's asking you, it's saying, okay, so now we know the velocities of Angela and Blake. And so then our velocity versus time graph, we can just quickly make like we did in the previous section. The next scenario, we have a buggy that is moving at a constant velocity. And it's moving at a constant velocity of 5 meters per second for 10 seconds. And so the first thing is it's asking you to make a velocity versus time graph. And so we got velocity and time, and we see here that the buggy is traveling at a constant 5 meters per second for 10 seconds. If you find the slope of a velocity versus time graph, that is, we haven't talked about this yet, but the slope of a velocity versus time graph actually tells you the acceleration of an object. And so it makes sense that because the buggy is moving at a constant speed, in this case, the acceleration is 0 meters per second. We'll talk about acceleration, though, in a couple classes, so no need to stress about that. I think I really do want you to focus on, though, is the next couple parts, parts C and D. It's asking you how far using the velocity versus time graph, how far does the buggy travel? And the key here, remember, is that if we have a velocity versus time graph, the area under the velocity versus time graph is the displacement. So on a velocity versus time graph, the area is how far the object travels. And so here, the area is 10 seconds times 5 meters per second, right, to find the area of that rectangle. And so the displacement here is 50 meters because the seconds would cancel out. And so that's the key. The key here, right, is that the area under velocity versus time graph tells you how far an object travels. Last thing. In the last scenario, the buggy was traveling at a constant speed. Now the buggy is traveling, but it is speeding up. So we're getting that at time 0, it wasn't moving, so the speed's 0. At time 2 seconds, it was traveling 4 meters per second. And at time 4 seconds, it was traveling at 8 meters per second. So if we make a velocity versus time graph, we see that the car was speeding up. Now the question is, we can skip the acceleration part for now. Don't worry about that. Now the question is, how far in this 4 seconds, how far did the buggy travel? Well, in order to figure that out, we would find, again, the area under the velocity versus time graph, except this time it's a triangle. So we would have to do, remember the area of a triangle is 1/2 the base times the height. And again, the point being that the displacement is the same thing as the area under a velocity versus time graph. Not a position versus time graph, a velocity versus time graph. That, folks, is all I got for you. Hopefully this video helped answer some questions you had about the homework assignment. Really, really appreciate you sticking all the way to the end, and I will see you in class soon. All right, see you later. Bye.